In this video, we will make full description of our paper entitled Qualitative and Quantitative Risk Analysis of Unmanned Aerial Vehicles Missions over the Internet. Our methodology consists in using two approaches for UAV safety risk analysis: 1. A qualitative functional safety analysis approach, and 2. A quantitative analysis. The first approach combines the safety standards ISO 12100 and ISO 13849. The second approach is a quantitative evaluation method based on Bayesian networks. The proposed approach consists in a structured methodology that combines the ISO 13849 and ISO 12100 standards in order to derive the safety requirements of the drone operations when teleoperated and monitored through the Internet. The qualitative analysis approach has two phases. Phase 1 is related to the standard ISO 12100. Phase 2 pertains to the standard ISO 13849. First, a risk analysis is carried out to identify the hazardous conditions, along with their possible causes and their consequences that affect the safe operation of UAVs. Then, we identify all risks that are not tolerable in the risk evaluation step, and then, we try to reduce the risk to a tolerable level by following risk reduction measures. After completion of risk assessment and risk reduction following ISO 12100, we move to ISO 13849 to provide safety specifications and guidance on the determination of a required, adequate, level of functional safety in the form of a required performance level, PLR. First, according to ISO 12100, a risk analysis is carried out, which starts with system limits specification. The drone limits is divided into 5 categories: physical, temporal, environmental and behavioral limits, networking limits. This table explains the 5 categories and provides concrete examples and description of the limits. The second step of the risk analysis consists in performing hazard identification. The list of potential drone hazards can be either external and internal. This list was identified using reactive methods. Reactive methods are incidents and accidents databases, safety and flight reports, maintenance reports and survey. The third step of the risk analysis is the UAV risk estimation. The risk estimation consists in determining 2 parameters, the risk severity and risk probability. The risk level is determined using the risk assessment matrix. In the risk evaluation step, we identify all the risks and that are not tolerable, hazards that led to an unacceptable level of harm, and then we will process them in the risk reduction step. According to ISO 12100, there are 3 steps to follow for risk mitigation: inherently safe design measures, safeguarding and information for use. After completion of risk assessment and risk reduction following ISO 12100, we move to ISO 13849 to provide safety specifications and guidance on the determination of a required, adequate, level of functional safety in the form of a required performance level, PLR. The first step of ISO 13849 is to identify the safety functions to be performed. In the second step, we calculate the required performance level, PLR, to specify the ability of safety-related parts of the system to perform a safety function. PLR refers to the performance level that must be applied to attain the required risk reduction for each safety function. According to ISO 13849, the required performance level PLR is estimated using the following risk graph. The PLR is determined by estimating the 3 parameters: severity of possible injury, S, frequency of exposure to hazard, F, and the possibility of avoiding the hazard, P. In the quantitative analysis part, we use Bayesian networks approach to conduct a more detailed analysis of the relationships among risk of drone crashes and their causes to prevent the crash from occurring. The first step is creating Bayes' model of the UAV crash risk, based on the safety analysis output described in ISO 12100 and ISO 13849. Due to limitation of concrete data of drone crashes, we collect data through a review of previous research papers, multiple online accident and incident databases. Using the AGENA risk software, a UAV crash due to the combination of the internal and external factors considered will occur with a frequency that is negligible. 60.106%, low, 6.456%, medium, 7.128%, high, 8.348%, and very high, 17.961%. To illustrate the performance of each risk factor's contribution to the occurrence of crash accidents of UAV, we conduct a sensitivity analysis. From the tornado graph, the external sources has by far the most contribution to crash. The frequency of crash given the result of external sources go from 0.102, when external sources occurrence is remote, to 0.531, when external sources occurrence is frequent. The vertical bar on the graph is the marginal frequency for crash being true, 0.18.